Hi, my name is Rudy Flores. I'm an undergraduate electrical engineering student at the University of Texas at El Paso. This summer, thanks to Lewis Stokes Alliance, I was able to conduct research in Dr. Benjamin Flores' radar laboratory. My research is based around an electromagnetic property of objects, known as the radar cross-section. In layman terms, how detectable something is. This was a big goal, and so it became utterly necessary to know how the radar works in general. A radar works by propagating electromagnetic energy from a transmitting antenna towards a target. Once the energy strikes this target, some of it scatters back towards the receiving antenna, which can be read on a spectrum analyzer. In radar engineering, this phenomenon can be explained by the radar equation. Through the use of this equation, we were able to set up our experiment in such a way that the only thing that would affect the power received at our analyzer would be the radar cross-section. The transmitted power is held constant by controlling the voltage and the current supplied to the Klystron power supply. The wavelength, or its equivalent frequency, were also held constant through the use of a C-band oscillator. Two identical antennas were chosen to eliminate gain as a variable as well. It was also important to know where our energy would be going as it propagated, so we applied the half-power beamwidth formula. Consequently, we were able to draw a field. These 5 objects were swapped into the field at 20 inches, where they would all be fully illuminated. We found out that a sphere, relative to a cylinder, reflects less energy. This is because it has one point of reflection. A cylinder has a line of reflection. A flat plate, relative to a cylinder, has a surface rather than a line. Adding more surfaces allows us to echo back much more energy. So a dihedral plate echoes back more energy than a flat plate, whereas a trihedral echoed back the most energy. Our results were fairly accurate, at most 1 dB off. It showed that Werner's estimations could be used in order to develop much more complex radar cross-sectional models, for example in a plane, where the engine might be seen as a cylinder and the tail as a flat plate. In the future, I plan to incorporate a combination of these objects and develop much more complex models. Thank you.